Okay, this is part two. That's part two of the exam prep. We're gonna aim for Limpopo 2025 and NSC 2025. This is part two of stats again, and this is the Limpopo paper. Okay, so the table below shows the average weight and standard deviation, okay, of packets of chips from different distributors. Its independent quality controllers investigated the weight of the packets of chips to see if the distributors are complying to the rules. The packets are all marked to have 130 grams of chips in them. Okay. We got distributor A, B, C, D. Generally, they're all close to 130, so it's fine. The standard deviation is 4. That's okay. Let's go with the first question. It says 1.1.1 says if 2,000 packets of chips were investigated from distributor C, what is the total weight of chips that was tested? Okay, so this is generally an easy question because we would go to distributor C, and distributor C has an average weight of 130 grams, and then they investigated 2,000 packets of chips. So that means, do they want it in kgs? No, they don't, so it's fine. 2,000 packets times 130 equals to 26. Let's go 26,000 grams. That's all there is to this. This should be quite simple. I don't think you guys should have a problem with this. So 260,000 grams. If they want it in kgs, by some chance divide by 1,000, that's 260 kgs of chips. They did not ask for that, so there's no need for you to panic. Let's go with 1.1.2. Which one of the distributors is the best to buy from? Give a reason for your answer. So if I look at all of them, generally, most of you would say average weight is B. A lot of you would say that, and I mean, it makes sense. You look at it and you see the average weight is 132, and that's the most chips. But if we look at the standard deviation, we can see that D has the smallest standard deviation. And the grams of the packet, let's go where the grams of the packet should be 129. So I look for the lowest standard deviation. Most of you would get tricked by B. B is 132, and that's fine. I mean, in general, you might be the lucky one that gets 132, but a lot of it is a trick. So we go and we look at the lowest standard deviation, and the smallest standard deviation would be for D. And the average grams of the packet is the closest to 130. That's what we start to look at. So D would be the best one. So D has the lowest standard deviation, but also it has the closest. It is the closest to the mean. Well, it's closest to 130 grams. Let's say that. Okay, guys. Just a quick mistake there. That was 2,000 grams. We did calculate correctly. We just wrote 200 grams, but that's fine. With 1.2, a lot of you must be thinking, why did I not pick 132? And why did I pick the one with the lowest standard deviation? So what does the standard deviation actually mean? The standard deviation is the number that shows how far the values in this group of data is spread out from the average or the mean, right? Which is the same thing. So when we have a low standard deviation, it means the numbers are close to the average. And a high standard deviation means the numbers are spread further away from the range. So the fact that we have the lowest standard deviation is 1, that means all the numbers of the weight is very close to 129. With this one, even though this has a higher average, a lot of the data is more spread out from the average. So we might get a few like 128s or 127s, but this one is the closest. So look for the lowest standard deviation and the closest to what we need. Okay, so that's quite simple to deal with. 1.1.3, Says, which one of the distributors would you rather not buy from? And give your reason. Okay. Now, if we look at this, firstly, I would prefer not to buy from distributor A. The reason is they have the lowest average. So that means you're getting the least amount of chips from them. But they also have a very high standard deviation. And a high standard deviation means that they're very far away from the average. So they could be way above the average or way below the average. But the truth is, they're very far from 130. They're 5 grams short from 130. So I would stay away from there. So let's go with a proper reason. Even when the packets are filled above the standard deviation of the mean, they do not fill it up to the recommended grams, which is 130 grams. So we can end on this point. Okay, guys, we continue with this question 1.2. The following histogram represents the length of a number of fish caught in freshwater angling competition. The shortest fish was 9 centimeters and the longest one was 58 centimeters. That's already min and max in case you wanted a 5-number summary or a box and whisker. But let's start the range. The range would be the length of the fish. So it will be the max minus the min. And they gave us the max was 58 centimeters and the minimum was 9 centimeters. So the range is 49 centimeters as a range. Quite simple to deal with. And they want us to complete the frequency table. Guys, to complete the frequency table, we would need the values. It does make sense. This is 3, this is 15, and it continues. If they did not give us the frequency, you would estimate. We would see this is 27, that's 45, that's 38, and that's 12. Now, again, please understand that this most likely is going to ask you for an OGF curve or a frequency polygon. So let's start with the first question wants a cumulative frequency. So we go here. That would be 3. Then 3 plus 15 is 18. And then we continue. 18 plus 27 is 45. So you add that way and you write down the answer here, 45. 45 plus 45 should be 90. 90 plus 38 should be 128. And 128 plus 12 should be 140. It makes sense. Please understand that this end of the cumulative frequency is technically the max. So this would be the max that we deal with, which is 140, and that's fine. Draw an OGF curve in the answer book to represent, okay, cool, the data. Now guys, drawing an OGF curve is going to be difficult for me with my graphic tablet, but what I can do is give you the proper OGF curve from the marking guideline. I can teach you how to draw it. I just don't want to make this booklet untidy because I do want to send you guys this booklet. So an OGF curve is where we plot the cumulative frequency and we plot the intervals given to us, right? If we look at this, there's 3 parts we do need before we start. I want you guys to learn to label title, y-axis, x-axis. The y-axis is the cumulative frequency. The x would be the intervals. Now the intervals, they have a very broad interval spectrum, but I wouldn't prefer 20s. I would go in 10s. So from 0 to 10, that's 20, that's 30, that's 40, that's 50, 60, and 70. And whatever works for you works, but please remember that 0. See this value that's here? This is a problem value, which is 0. And then we need to work with a little bit more, okay? So we're going to start with 10s. This is our values that we're going to go with. We're going to go with 10, 20, 30, 40, 50, 60. So the 10 is going to get the 3, the 20 is going to get the 15, 30 is there, and it continues, right? Not actually the 15, but let me try and draw this one. The 10 is going to get the 3, the 20 is going to get the 18, the 30 is going to get the 45, the 40 is going to get the 90, 50 is going to get the 128 and 60 is going to get the 140. So let's go again. We can look at it and see that, let's try. The 10 value is going to get a 3. Unfortunately, I'm not able to draw this properly, but the 10 value gets a 3. We can see the 20 value is going to get an 18, which is somewhere there. We can see that the 30 value is going to get a 45, which is somewhere there, right? I'm trying, guys, to just make it a bit easy for you. The 40 is going to get the 90 value. Makes sense because the value is quite okay. And there, the 50 is going to get the 128. Okay, if we look at this, the 50 should get the 128 that's there. I'm going to add the points to the graph just so you see. And the 60 would get the 140, right? Let's add some points to this just so you guys figure it out. And we'll work with it, right? The first point I would draw is 0 and 0. The next point I would draw is 10 and 3. 20 and 18. 30 and 45. 40 and 90. I would aim for 50 and 128. And I would aim for 60 and 140. And that would be my Ujev curve. Please understand, this part would trick you. The first one that's drawn, the 0 would be 0. We'd start off at the 0 point, and then this 10 would start off with the first cumulative frequency. But if you get stuck, always work backwards. Start with the maximum, would get the maximum, and we continue going that way until you're going to see that, hey, something works out because whatever value is here is going to start at the 0, because sometimes that value does not start at 0. So we need to work with that one. And 60% of the fish are less than X centimeters long. Use the Ogive curve to determine the value of X. Okay, guys, again, 60% of the fish are less than X centimeters long. Use the Ogive curve to determine the values of X. So I'm going to remove all of my points because I did show you guys this. What I would do is take 60% of the total. So I would take 60% multiplied by the total, which is 140, and 60% times by 140, and that equals to 84, right? I would go to my graph and I would look for 84, so that's 80. I don't know how my scales work in. Is this 5, 10, 15, 20, or 4, 8? Okay, I think it's moving in 4s. So 84 would be the first line. Okay. Now, guys, again, if you have your pencil and your ruler, it's simple. But 84 goes there. And then it comes down there. So you would get an error of, I think, 0.1. We should be fine. Or you should get about 2. So it should be a range of, you could have an error of 2. So what's going to happen is this is less than 40. It's bigger than 38, so maybe 39. So what percentage of fish is there? X is less than 39. Because 60% of the fish would be there. That is 60%, guys. So 60% of the fish is less than 39 centimeters long. And that's the end of this question. Okay, guys, this is question 2 on the Limpopo paper. It's also simple as well. We can deal with this quite simply. The top 10 athletes in a certain province took part in a provisional biathlon championship. They had to participate in a 10-kilometer cycling and 3-kilometer swimming. Okay, cool. The following table represents the times each athlete for cycling and swimming, respectively, recorded in the championship. Now, both these in times, you can decide whether it's X or Y, but this would be a scatter plot, guys. For example, you would put cycling maybe there, You would put swimming maybe there, and you would think of it as X and Y. It didn't matter in this case. So just say this is 22, and just say that's 39. You would go up there, and we would put our point there. And that would be athlete 1. We would label athlete 2, 3, 4, 5, 6, all the way to 10. But in this question, we do not need that. The first question asks us to determine the average cycling time for the athletes. Okay, so the average cycling time for the athletes would be, you and I would take all of the cycling values, add it up, and when we add it up, we should get 222, and we would divide it by the total number of athletes, which is 10, and the average cycling time would be 23.2. That should be the end of this. Quite simple. Average means mean. You could use your calculator if you want to, but that should be fine. Now, guys, we did this in the previous videos quite a bit. Determine the equation of the least squares regression line. This is where we need A and B. So we're looking for A plus BX. The least squares regression line looks like this. Y equals to A plus BX. Please remember this is a straight line. So if it is a straight line, the B is the gradient, and this controls a lot of things. How do we get the least squares regression line? Firstly, we press mode. Okay, so again, we're going to go with mode. We're going to go with stat. We're going to go with A plus BX. You're going to end up with a table of X and Y. You're going to enter values. You're going to enter the values. You're going to press AC. Remember, you choose your X and Y. You're going to press Shift Stat. You're going to press regression line, and you're going to have A, B, and R. These are the important ones that we get. But when you do all of this, what's going to happen is A is going to be equal to 19.86. B is going to be equal to 1.22. And our formula, which they want, is Y equals to A, which is 19.86, plus 1.22x. And that should be the end of this question. Calculate the expected time for an athlete to complete the swimming event if he takes 29 minutes to complete the 10K cycling. Okay, guys, again, just before we do this question, they could ask us for the R value as well, and you would just use the R value, Shift, Stat, Regression, and press R, and we should get it. But 2.3 is quite simple. Y equals to 19.86 plus 1.22. Our X value is cycling, so we're going to put cycling there as 29. And we should get Y, which is the swimming, should be 55.4 minutes. This question is simple because if they gave us the swimming, we could substitute it for Y, and we could calculate the X value quite simply. That's all there is to this question. Okay, guys, again, this would be the NSC paper. It would be 2025. And the stats is quite simple again. So let's work with this question. It says there were 11 cars of the same model for sale at the car dealership. The age, well, which is in years, of each car and its corresponding selling price in grams is provided in the table below. Okay. Determine the equation of the least squares regression line. Quite simply, we would look at age and we would look at selling price of the cars. So you and I could deal with this. We could start off by saying, okay, cool. They want Y equals to A plus BX. We just did this question. Mode, stats, A plus BX. You're going to enter your X and Y values. But for now, we're not drawing, so it's fine. You can put your X and Y values. Thereafter, you can press AC, press Shift Stat, press REG. You go to the one that says A, and we're going to write down our A value equals to 331, 397.20. Our B value equals to minus. Now this one is tricky. Minus 22, 988.32. And that's fine. Our gradient is negative. That means it decreases as the years is increasing, but we can see y. Our final answer would be y equals to 331,397.20 plus, I got no space, well, minus actually, minus 22,988.32x. And that should be the answer. Done. Predict the selling price of a similar car at the dealership that is 5 years old, right? If the car is 5 years old, it is easy to deal with. Okay? Y equals to, depending if you took this as x, right? You needed to take it as x and y. Y equals to this formula. Guys, I think I'm running out of space, so let's try and put this somewhere else. So prediction uses this line, 331, 397.20 minus 22, 988.32. And we're going to put this as 5 because that's the years. And now this is how we predict the price. And the price of the car after 5 years would be 216,455 rand and 61 cents. You could use your calculator to solve this quite simply. I don't think it would be a major problem, but yeah. Note this is the NSC paper. It is quite simple. Use the correlation coefficient to show whether the prediction made in 1.2 is valid or not. So firstly, you guys did not get the coefficient, but it is the R value, which is equal to negative 0.95. We get this by pressing Shift Stat. Your data should still be in the calculator, and you're going to go to REG and press the R value, and this is negative 0.95. Okay. Now, guys, let's work together and sort this out. Because it is negative, we're going to have a negative relationship. And because it's closer to 1, it's going to be a very, very strong negative relationship. So it's going to have a negative, strong correlation. It's going to suggest that the data points lies really, really close to the regression line or to the line of best fit. Now, what that means is because it is a strong correlation, that means all the data lies closer to the line of best fit or the regression line in general. And if it lies closer to the regression line, that means that this prediction has to be valid. And that's all there is to this question. Let's go with the next one. Use the answer in 1.1 to write down an estimated average yearly decrease in selling price of these 11 cars. So what we can do is understand that the average or the average decrease in general per year, per 1 year, would come from the B value. And the B value in this question was minus 22,988.32. That would be the simple way to deal with this question. Okay, this is question 2 on the paper. The cumulative frequency table below shows an amount of time that people spent on a particular website on a certain day. We get 0 to 20 minutes. Oh, it's equal to 20. Okay, 0 to 40 minutes, 0 to 60 minutes, 0 to 80, 0, all is 0. Okay. How many people visited the website on that day? So if we look at it, remember, cumulative frequency means we keep adding the frequency to the previous number. So when it comes to cumulative frequency, the last value is always the total. The total number of people that joined this day was 70. Now, how many people spent more than 40 minutes and up to 80 minutes on the day of the website? Now, questions like this are a little bit iffy, but people that spend more than 40 minutes a year, so 40 is here, less than 80 is here. So we want to find the people that's in this range, in this middle range. So we would take the cumulative frequency of 67 minus the cumulative frequency of 40, and we can find the frequency of people that stayed in that range is 27. Again, we want more than 40 and less than 80. So we only care about this range of people, 67 minus 40. And then that's what we're aiming for. Let's try and use a different color so when you guys are learning, it doesn't confuse you guys too much, but that's the range we're looking for. Okay, 67 minus 40 equals to 27. Now, guys, the next question is, oh, that's on the wrong part. The next question is they want us to draw a histogram. Since I'm sending you guys this document, I'm not going to draw it on my own, but I will explain it. This is the question that we'll be dealing with. I think it can fit next to it, actually. Cool. So this is from the marking guideline. Remember the three important parts first. Before you start drawing the diagram, make sure that you write down the label, the graph. But I would prefer the saying graph showing time versus cumulative or time. What is this? Draw a histogram to represent the information. Yeah, time versus or histogram showing time versus cumulative frequency table. It is quite simple. We'll deal with it a little bit differently, but we would start off from 0 to 20. Now, this part is tricky, right? 0 to 20. Okay, guys, I'm going to remove all of this because it might be difficult to see. But if we needed the frequency of this table, this would be 16. This would be 40 minus 16 would be 24. 59 minus 40 would be 19. 67 minus 59 would be 8. And 70 minus there would be 3. So this is frequency, guys. We worked backwards to get the frequency. And that's what they drew in this table. So this would be 16 goes to 20. Then from 0 to 40 goes to 24. And it continues in that part. From 0 to 60 would go to 19. That's how I got it there. From 0 to 80 would go to 8. And from 0 to 100 would go to 3. The reason I didn't draw it is because I would prefer you guys to have a neat copy of it so you can see. It's difficult to draw on the tablet, but this is generally what would happen. And this would be a level 1 question. Now, if they asked us, where is the data skewed? I would like you guys to learn about skewness. You see, when data is growing this way, when the diagram is going bigger towards the right, the data is skewed to the left. But when the data starts up higher and starts going down, the data is skewed to the right. So our general trend of data is skewing to the right. Okay, so this would be a right skew. Or instead of right, you could say positive. But for the next question, we have quite a simple question, but it is 5 marks, so let's not mess it up. There are 9 players in the basketball team, and the coach calculated on average, each player scored 12 points during the game. The points scored by 8 of the 9 players of the team are given below. How many players scored? How many players points score was outside one standard deviation of the mean of the score? Okay, guys. This is quite simple. You and I don't have to panic. We got 1, 2, 3, 4, 5, 6, 7, 8. We got 8 players, right? So what that means is you and I would say 11 plus 14 plus 19 plus 20, plus 8, plus 10, plus 2, plus 14. Now, this was 8 out of 9 players, so that means one player is not here. Let's call this player K, plus K for Keegan. So if we take that, and if we divide it by 9, we should get an answer. So let's add all of this up. This is 11, plus 14, plus 19, plus 20, plus 8, plus 10, plus 2, plus 14, and that's 98. So this is 98 plus K over 9. And he told us that the average is 12 points. So this was equal to 12. Equal to 12. And then let's solve quite simply. If we solve it, let's take 9 over as multiplication. 12 times 9 is 108. So this would be 98 plus K equals to 108. And then K equals to 108 minus 98. So that's 108 minus 98. And K equals to 10. So this guy that was here was 10. Right? So that was part 1. That would count for quite a bit of marks. Part 2 would be for us to calculate the, sorry guys, my screen just switched off. Part 2 would be for us to calculate, I mistakenly deleted whatever I had. Okay. Part 2 would be for us to calculate the standard deviation. Now the standard deviation in general is quite simple. Let's move this one side. I try to make it a bit smaller, but yeah, it's not cooperating. Yeah, okay. English is not Englishing, guys, but let's try and do the standard deviation. The standard deviation of this would be quite simple. It would be mode equation, mode stat variance. You would enter in the values, and after we enter in the values, you would press AC. You would press shift stat. You would press variance again, and you would look for the value that looks like that. And when we get this value, it would be 5.22 or 5.23. Now that we got this, we need to understand the third part of this question is quite simple. We got the mean, which is here, which is 12, and they want to know how many players' points score was outside one standard deviation of the mean. So outside means I'm going to go that way. I'm going to plus the standard deviation, and I'm going to go that way. I'm going to minus the standard deviation. So when I plus the standard deviation, let's just go here, plus 5.23, and then minus 5.23, and let's see what happens. So 12 plus 5.23 is going to equal to 17, some change, 17.23, and 12 minus 5.23 is going to equal to 6.77. Now, this is the range, guys. They did not say within one standard deviation. They said outside one standard deviation. So now I'm going to look for everything that's less than 6.77. 6.77, 6.77, that's 1. That's less. And let's look for everything above 17.23. Above 17.23 is there and there. So altogether, how many players fall outside one standard deviation would be 3 people. And that's all there is to this question.